This problem on Lebesgue integration is from GATE 2021. It says f is a function defined on the closed interval 0, 1 to r by fx is equal to 0 when x is rational and x belongs to 0, 1, and fx is 18n when x belongs to 0, 1 minus rational. That means the irrational points in this interval 0, 1, where this n is, let's suppose x can be written as d1, d2, dn dot dot dot. Okay, so here n is the number of zeros, the number of zeros immediately after the decimal point. Up to what? Up to the first non-zero number. Let me explain you. If x is equal to 0.00123, okay, but this is for irrational, so we will write 0.01235 etc. dot dot dot. That means x is an irrational lying in this interval, and there are exactly 2 zeros right after the decimal point. If there is another 0, we will not count it, like 0, 6, 7 dot dot dot. We will not count this 0. We will count only these 2 zeros. Okay, so the functional value of x will be 18 into 2 in this case. And if x is a rational number, then the functional value will be 0. Okay, now we will arrange this function in a better way. So let me write it as fx is equal to 0 whenever x belongs to 0, 1 intersection q, and fx is equal to 18 into 0, 18 into 1, 18 into 2 dot 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 when x belongs to this interval 0.1 to 1 minus q when x belongs to 0.01 to 0.1 minus q. Why we are dividing this interval 0, 1 into these subintervals? Okay, let me explain. When x, this will be an open interval, right? This will be open. If x belongs to 0.1 to 1 minus q, then x will be of the form 0.235 dot dot dot, or x can take the value 0.356 dot 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 etc. Okay, why? Because these all numbers lie between these 2 points, right? And notice there is no zeros right after the decimal point. So in this case the functional value will be 18 into 0. The value of n is 0 here. When x belongs to 0.01, 0.1 minus q, in that case x will be what? X can take the value 0.02, after that 3, 6, whatever. X can take the value 0.03305 whatsoever, etc. This 2 and this 0.02 dot 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 lies in these 2 points, right? This point is bigger than 0.01. So in this case there is exactly 1 0. So The functional value here is 18 into 2. 18 into 1 is equal to 18. Okay. Similarly, when we divide the interval in these subintervals, then the functional value will be respectively 18 into 0, 18 into 1, etc. and so on. Now notice something. What is the length of this interval? The length of this interval is 1 minus 0.1, which is what? 0.9, or we can write 9 over 10. What is the length of this interval? It is 0.1 minus 0.01, which is 0.09, or we can write it as 9 over 10 square. Similarly, the length of the next interval will be 9 over 10 cubed, 9 over 10 to the power 4, and so on. Now, if we take out the rational points from this interval, what will be the length? We know the set of all rationals is a set of measure 0, right? So if we take out all the rational points from this interval, the length of this interval still remains the same, which is 9 over 10. Similar for all other subintervals. Now let me define a function. Gx is equal to 18 into 0, 18 into 1, 18 into 2, ... when x belongs to 0.1 to 1, including rationals also. When x belongs to 0.01 to 0.1, when x belongs to 0.001 to 0.01, etc. Okay. Now see, here fx is equal to gx for all irrational points, right? But fx is not equal to gx when x is some rational point. Now we know that, as I mentioned earlier, that the set of all rationals is the set of measure 0. So we can say that fx is equal to gx almost everywhere in 0, 1. So what does this almost everywhere mean? That means the points at which fx is not equal to gx, if we collect them as a set, then the collection is a set of measure 0. That means this set E, where x belongs to 0, 1, such that fx is not equal to gx, this set E is a set of measure 0. Then we can say fx is equal to gx almost everywhere in this interval. And now we will find the integral value. 0 to 1 fx dx will be equal to 0 to 1 gx dx, because gx is equal to fx almost everywhere in this region, this interval. Okay. Now we will put the functional value into the interval plus functional value into the interval. Functional value into the interval, and so on. Now see, it will become 18 into 9 over 10 square. This term is 0, so we will calculate from this term, plus 18 into 2 into 9 over 10 cubed, plus 18 into 3 into 9 over 10 to the power 4, plus so on. Now we will take 18 into 9 in common. So what remains is 1 over 10 square plus 2 over 10 cubed plus 3 over 10 to the power 4 plus ... So again we will take 1 over 10 square in common. Why? Let me explain you. 1 over 10 square in common, so it will become 2 over 10, 3 over 10 square, and so on. Now we know the formula that 1 plus 2x plus 3x square plus dot 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 is equal to 1 minus 1 minus x whole to the power minus 2 when x is modulus value of x is less than 1. Right. We will use this formula to calculate this sum. Okay. It remains as it is, 18 into 9 over 10 square, and since here x is 1 over 10 which is less than 1, so we can write it as 1 minus 1 over 10 whole to the power minus 2. Now it will become 2 into 9 squared over 10 squared, and this one is what? 9 over 10 whole to the power minus 2, and see, this one is 9 over 10 whole square and this one is 9 over 10 whole to the power minus 2. So these two terms cancelled out, we get only 2. So this is the answer. So thanks for watching the video, and if you don't understand anything, let me know in the comments.